So, my name is Gideon. I'm a developer at Riskified. Today we're going to do a streaming shootout, and we're going to compare two of the main streaming libraries in Scala. So before we actually do that, we need to understand the motivation behind streaming libraries in general. So imagine that we have a producer and a consumer, and at some point in time, the producer becomes faster than the consumer. This causes events to come at a rate which is faster than what the consumer can actually process. This can cause us to drop events or even run out of memory. The solution to that is slowing down the overall consumption rate to match the consumer. It's not ideal because it means we are now slowing down the overall consumption rate of the system, but it does mean that we're avoiding the problems that I just mentioned before. This is exactly what streaming libraries do, and they incorporate BACKPRESSURE as part of their architecture. Today we're going to focus on these two, Akka Streams on the left and Monix on the right. So let's introduce Akka Streams. It's maintained by Lightband. It's a really big and powerful library. It has other abstractions beside Akka Streams like Akka Http and Akka Actors, which I bet you all know. And what's nice about Akka Streams is that it's very modular. It allows us to compose a lot of small streams into bigger ones. Now let's introduce Monix. So, Monix was created by this guy, Alexandru Nedelțu. He initially created this library in order to monitor nuclear power plants. Monix is also a part of a bigger library, and Monix has the Monix Task, which is the equivalent of a Scala future, only it's much better. And it also has Monix Observables, which is the part that does the streaming in Monix, and it's also what we're going to talk about today. Monix is highly inspired by other reactive streaming libraries, and its main philosophy is trying to keep things as simple as possible. Okay, what we're going to do next is we're going to look at a very simple example, a hello-world example in streaming with both of these libraries, and we'll compare the two. So this is how the code looks like in Akka Streams, and we'll go over it now. So the first thing we do is we produce user IDs into the stream. Next, we use map async in order to integrate futures inside the stream. Now, find user may not return a user, so it returns also an option. That's why we need to flatten the non-existing options. Next, there's the map and filter, which I bet you all know by now. And also we use scan, which is like a fold, and it emits values for each incoming element in the stream. We also have to drop one because Akka Streams emits the 0 value. Lastly, in order to save the result to a file, Akka Streams provides us with a set of tools to do so. This is how the same code looks like in Monix. I'm only going to go over the interesting parts here. So we use observables in order to produce user IDs into the stream. We use map future in order to integrate futures inside the stream. And eventually we don't get any tools to do the actual file I/O, and we have to roll our own implementation to do so. This is intentionally blurred, and the idea is just to show you that they take more or less the same amount of screen real estate. So these two examples are very much the same, but there are some differences here. So, Akka Streams uses source in order to produce user IDs. Monix uses observables. Observable is a concept that is taken from the reactive streaming terminology, and it's also another indication that Monix is highly inspired by these libraries. Akka Streams uses actors under the hood, and that's why it needs the actor system and the actor materializer. Monix requires us to provide a Monix scheduler, which is the equivalent of a Scala execution context. In order to run async code, we use map async for Akka Streams and map future for Monix. What's interesting here is that Monix also provides a map async, but it expects a Monix task instead of a future. So it's interesting to see that Monix actually prefers its own abstractions over the regular ones. Lastly, Akka Streams provides us with tools to do I/O and stuff like that, while Monix delegates the responsibility to us. What I'm going to do next is take a few examples and criteria of things that I found interesting, and we're going to compare the two. So the first thing that we do while learning a new library is we look at the learning resources. So the official documentation is really good for both. You can see Akka's documentation on the left and Monix documentation on the right. As you can see, Akka Streams documentation is really nice and pretty. They're both pretty good. The problem with Monix is that it doesn't cover nearly as much ground as Akka Streams. Akka Streams also has books, a Gitter channel, and a lot of blogs. It also has quite a lot of questions on Stack Overflow. Now, I know it doesn't seem like much, but next we're going to look at Monix, and you'll see it's actually quite a lot bigger. And overall, it's really awesome if you think about it. Okay, so Monix is a different story. And when I started learning Monix, I was immediately able to write hello-world examples. But I really quickly ran into the lack of documentation in Monix. This made me feel lost. Then I discovered the Monix Gitter channel, which is awesome, and Alexandru, the guy that created the library, actually answers questions there, which is awesome. But I would argue it's still not enough. I'm going to share a pro tip that I discovered while learning Monix, and I'm going to share it with you now. So, a colleague of mine reminded me of the fact that Monix is highly inspired by other RX streaming libraries, like RxJS, and he suggested that I should look at the RxJS documentation and then try and implement it with Monix. It turned out to be a really good advice, and overall I would say it balances things out. So, if we want to sum the learning resources, it's a matter of taste. Do we prefer the powerful documentation over the exotic solution that Monix has? Next, we're going to look at complexity. Now, I know complexity is something that is not really fair to compare, because it's something that you get used to it, but I do think that there are some interesting differences here that we should look at. So we've already seen source, which is the part that produces elements into the stream. Sink is what consumes elements from the streams, and flow is what transforms values inside the stream. Now, Akka Streams has a concept called the materialized value, which allows us to receive a value from the stream once we execute it, and then do something with it. You can see it in the not used type. It obviously can be other types as well, but this is just an example. It allows us to do really powerful things like a kill switch, which basically allows us to kill the stream from the outside. But it also generates some really weird looking code, especially when you first look at it at the beginning. Monix, on the other hand, has a lot less concepts to deal with. And also the source code was relatively easy to look at. So if you don't understand something, it's really easy to just look at the source code, at least in my opinion. The downside is that it may require us to roll out our own custom implementations for stuff like a kill switch, for example. So it's basically all about trade-offs regarding complexity. Do we prefer to have the Akka Streams way of having our overall stream more complex, or do we prefer to have our overall stream looks nicer, but at some point it may be even more complex because we have to roll our own implementation? Next, we're going to look at the ecosystem. So I'm going to show you an example of Akka Streams with Akka Http. This is most of the code that we need in order to produce an Akka Http server with back pressure built into it. These are the interesting bits here. And if you think about it, this is a really powerful concept because we get an HTTP server with back pressure built into it. Monix integrates nicely with cat. So imagine that we have a method that expects a cat's monad. Now, if you don't know what a monad is or what cat is, it doesn't matter. You can just look at it as another type class. This is basically all we need to do in order to have a type class for a monad with cats, in this case, for observables, Monix observables. And it's really awesome if you're working with cats. It's like it blew my mind. So this is basically a matter of taste, and there's no clear-cut winner. Lastly, we're just going to compare integrations. And what I mean by integrations is how we integrate with external services. So Akka Streams has a library called Alpaca, which allows it to integrate with external services. These are just a few, and there are many more. Monix, on the other hand, only integrates nicely with Kafka. I would argue that Monix definitely loses here, and Akka Streams is far superior. Okay, so it's time to sum everything up. Both of these libraries are very powerful. Each has its own strengths and weaknesses. Each one has its own philosophy, which are almost orthogonal to one another, and they both use it in order to do reactive streaming. I'm going to summarize everything that I just talked about in this slide. So choose Akka Streams if you need really good documentation, integrations with external services, or with the rest of the Akka system. And if you're looking for modularity in your streams, then Akka Streams is also a good choice. Choose Monix if you're coming from an RX background, or if you want to integrate nicely with the CATS ecosystem or with Monix. Or if you're just looking for really simple solutions for most of the problems. Okay, so we're done. I'm just going to wrap up. There are two things that I want you to take from this presentation. One is that streaming is really powerful. Obviously, I don't have enough time in 10 minutes to show it to you. but I encourage you to look at it at your own time. 2, you shouldn't just know one, you should know more than one. This is the only way to become a better programmer, and it also gives us the right tool for the job when we need to. Thank you, and if you have any questions, you're welcome to talk to me at the Riskified booth.